Lesson 19, solving one-step equations by adding or subtracting. Some vocabulary. Just an equation, review. Equation is just a statement with an equal sign that shows that two quantities are equal. So if both sides are not equal, you should not have an equal sign in between. And the solution of an equation when one variable, the value of the variable that makes the equation true. If they give you an equation with one variable, you need to solve for that variable, and that one variable is going to make that whole statement true. An equivalent equation is just equations with the same solution set. So if you have one equation and another one, each number that works for one equation also works for the other one. Those would be equivalent equations. They're equal. And inverse operations is operations that undo each other. So to undo addition, you do subtraction, or to undo subtraction, you do addition. Same thing with multiplication and division. They undo each other. And so those are the operations you're going to be using on both sides of the equal sign. And remember the golden rule of algebra. Whatever you do on one side of the equal sign, you must do on the other. So let's take a look at some examples here. X plus 6 equals 9 for x equals 3. We need to prove to see if that is a solution. So I plug 3 in for x. 3 plus 6 is 9. The other side is 9. So yes, this is a solution. Next one, put a 3 in for x. So 3 minus 6 equals 9. 3 minus 6 equals negative 3. The other side has 9. They are not equal, so no, 3 is not a solution. Next one, h minus 14 equals 2. For h equals 12, I put 12 in for h. Subtract 14, you should get 2. 12 minus 14 equals negative 2. Negative 2 does not equal 2, so no, 12 is not a solution. Then we have negative 11 equals j minus 4 for j is negative 7. Plug in negative 7 in for j. The side's still negative 11. Negative 7 minus 4 is a negative 11. They are the same, so yes, negative 7 is a solution. Next one, some properties of equality. The addition property of equality says add the same number to both sides of an equation and it still will be true. So if 2 equals 2, I can add the same number to both sides and it will still be true. So we add 3 to both sides, 5 equals 5, it's still the same. Likewise with subtraction property of equality, you subtract the same number to both sides of an equal sign and still be true. So if we start off with 10 equals 10, if we subtract 4 on both sides, still have 6 on both sides. Let's work with those today. So we need to solve these equations. X minus 3 equals 12. I need to use the inverse operation. And these are all one-step equations. So to get x by itself, the opposite of subtracting 3 is adding 3. So I show that on both sides because if I want to make sure that both sides of the equal sign are equal, I need to do the same thing on both sides. So x will end up equaling 15. And I can check my answer by plugging that back in. 15 minus 3 does equal 12. Next one, negative 15 equals n minus 8. Opposite of subtracting 8 is adding 8. So I must do that on both sides. N equals negative 15 plus 8 is a negative 7. The other side here, x minus 5 equals 17. The opposite of subtracting 5 is adding 5. So I add 5 to both sides. X equals 22. And negative 30 equals m minus 12. To get m by itself, you add 12 to both sides. I'm left with m on the right-hand side. Negative 30 plus 12 would give us a negative 18. Some other examples here. P plus 3 equals 37. The opposite of adding 3 is subtracting 3, so I subtract 3 on both sides. That leaves me with P equals 34. x negative 14 equals y plus 8. The opposite of adding 8 is subtracting 8. So I subtract 8 on both sides. End up with y on the right hand side. Negative 14 minus 8 is a negative 22. Next, a plus 7 equals 13. The opposite of adding 7 is subtracting 7. So I subtract 7 on both sides. I end up with 13 minus 7, which is 6. And the last one on this slide, we have negative 21 equals p plus 9. Opposite of adding 9 is subtracting 9. If I subtract 9 on both sides, I end up with p on the far right hand side. Negative 21 minus 9 is a negative 30. And a couple more examples. Here we're dealing with fractions. So remember, we need to have common denominators with our fractions. So I'm going to rewrite this one. So to make the common denominator 4 and 8 is 8. So I need to multiply this by 2 halves. So this would be 2/8 equals a negative 3/8. Now I can go about solving it. The opposite of adding 2/8 is subtracting 2/8. So I do that on both sides. So I'm left with x on the left hand side. Negative 3/8 minus 2/8 is a negative 5/8. And a negative 5/8 plus 2/8 gives us a negative 3/8. On the right hand side, need common denominators. So I can rewrite this. So half and 6 would be multiplied by 3/3. So I end up with d plus 4 and 3/6 equals 3 and 1/6. The opposite of adding 4 and 3/6 is subtracting 4 and 3/6. So I subtract 4 and 3/6. Here I have d left over. And on this side here, I can't take like 1/6, well 4 minus 3 would give us a 1. And 1/6 minus 3/6 would give us an answer of 2/6. These will all be negative. And this would, I can reduce 2/6. So this would be a negative 1 and 1/3. So a negative 1 and 1/3. And an application problem. Larry took the same test twice. On the second test, he scored 87, which was 13 points higher than on the first test. What was his first test score? So he took the same test twice. The second test, he scored 87. So let's do, so really it's the first test plus the second test. And the first test or the second test was 13 points higher than the first test. So if I take my 87, which is the second test, and so the second test is 87. If I take the first test plus 13 will give me the 87 because they said it was 13 points higher than on the first one. So the first one plus 13 gives you the score of 87. So I use my inverse operations to find out the first test. So I subtract 13 on both sides and I end up with first test score equaling 87 minus 13, which would be 74. So their first score, Larry's test, was a 74.